Security misconfigurations. Security misconfigurations occur when systems or applications are not properly configured, leaving them open to exploitation. These misconfigurations can include server settings, permissions, and more. Best practices for prevention. Secure defaults. Always change default settings and credentials. Failing to do so is a common misconfiguration. Ensure you don't use generic usernames and passwords. Least privilege principle. Implement the principle of least privilege. Users and systems should only have the minimum access required to perform their tasks. Regular security scans. Use automated security scanning tools to identify misconfigurations. Tools like OWASP, ZAP, and Nessus can help you detect and rectify security issues. Patch management. Stay up to date with patches and security updates. Outdated software often contains known vulnerabilities. Error handling. Configure proper error handling. Detailed error messages can provide attackers with valuable information. Customize error messages for a generic response. Secure file permissions. Restrict file permissions to the minimum necessary. Ensure that sensitive files and directories are inaccessible to unauthorized users. Cloud security best practices. If you use cloud services, follow cloud security best practices, such as configuring security groups and network access controls correctly. Employee training and awareness. Educate your employees about security misconfigurations. Teach them how to recognize and report potential issues, emphasizing the importance of correct configuration. Incident response plan. Develop an incident response plan for addressing security misconfigurations. Knowing how to respond promptly and effectively is crucial. In conclusion, security misconfigurations are avoidable, and by following these best practices and being vigilant, you can significantly reduce the risk of security breaches and data leaks. Take immediate action to secure your system from misconfigurations. Implement these security measures, educate your team, and ensure your system is properly configured. Cross-site scripting, XSS. Cross-site scripting, or XSS, is a type of security vulnerability found in web applications. It allows attackers to inject malicious scripts into trusted websites that are then executed by unsuspecting users. There are three main types of XSS: stored XSS, reflected XSS, and DOM-based XSS. Let's briefly explain each one. Stored, persistent XSS. This happens when user inputs are stored on the server and retrieved unsafely. It's the most severe type of XSS. Stored XSS is a type of web vulnerability where malicious scripts are injected into a website and then executed when another user visits that page. Impact of stored XSS. The consequences of stored XSS can be severe. Examples: data theft, cookie hijacking, session theft. How to prevent stored XSS. Input validation, output encoding, content security policy, CSP. Reflected XSS. This happens when user inputs are returned to the user without being stored in a database. Reflected XSS is a web vulnerability where an attacker injects malicious scripts into a website, and these scripts are immediately reflected back to a user's browser, executing upon viewing. User clicks on a crafted link with a payload. DOM-based XSS. DOM-based XSS is a web vulnerability where the attack payload is executed in the document object model, DOM, of a web page, typically by manipulating JavaScript. DOM-based XSS is similar to reflected XSS, except that in DOM-based XSS, the user input never leaves the user's browser. In DOM-based XSS, the application takes in user input, processes it on the victim's browser, and returns it to the user. How to prevent DOM-based XSS. Secure coding practices, input validation, output encoding. XSS typically occurs when a web application doesn't properly validate and sanitize user inputs. Attackers exploit this by injecting malicious code into a website, which is then executed in the context of the user's browser. Preventive measures. Now, let's discuss how to prevent XSS attacks. Input validation. Always validate and sanitize user inputs to prevent malicious scripts from being executed. Content security policy, CSP. Implement a CSP to control which scripts can be executed on your website. Output encoding. Encode output data to make it safe for rendering in a browser. Remediation. If your website is already affected by an XSS vulnerability, here's how you can remediate it. Identify vulnerable code. First, locate the vulnerable part of your code that allowed the XSS attack. Remove or sanitize. Remove or sanitize the malicious script and inputs on your website. Patch vulnerabilities. Fix the root cause of the vulnerability to prevent future attacks. Known vulnerabilities. Known vulnerabilities are weaknesses or security issues in software, hardware, or systems that have been identified and documented in open source, CVEs, etc. Let's understand the risks associated with known vulnerabilities. Data breaches, unauthorized access, malware infections. Staying informed, CVEs and security advisories. To stay safe, you need to be informed about known vulnerabilities. Common vulnerabilities and exposures, CVEs, security advisories. One of the best ways to mitigate known vulnerabilities is through timely patches and updates. Regularly update to software. Vulnerability scanners can be a valuable tool in identifying and mitigating known vulnerabilities. Tools like Nessus, OpenVAS, etc. In the next part, we'll continue explaining other vulnerabilities. Insecure deserialization is a vulnerability that occurs when an application deserializes untrusted data without proper validation, leading to potential attacks. There are two primary types of insecure deserialization: remote code execution, RCE, and denial of service, DOS. To protect your applications from insecure deserialization, you need to take proactive measures. Here are some practical steps to prevent this vulnerability. Input validation. Carefully validate data before deserialization to ensure it comes from trusted sources. Use safe deserialization libraries. Choose secure and well-maintained deserialization libraries to minimize risks. Implement proper access controls. Restrict access to deserialization endpoints and resources. Remediation. If you suspect insecure deserialization in your application, here's how to remediate it. Identify vulnerable code. Locate the areas of your code where insecure deserialization is occurring. Update and patch. Update your deserialization libraries and patch vulnerabilities to prevent further exploitation. Insufficient logging and monitoring. Insufficient logging and monitoring is a cybersecurity term referring to a situation where an organization or system fails to adequately capture, store, and analyze relevant data, logs, and lacks proper mechanisms to monitor these logs for suspicious or malicious activities. This deficiency can leave an organization vulnerable to security threats and cyberattacks. Insufficient logging. This occurs when a system or application doesn't generate comprehensive logs of its activities. These logs are essential for tracking events, user actions, and system behavior. Inadequate logging means that important security incidents or vulnerabilities may go unnoticed. Insufficient monitoring. Even if logs are generated, the absence of effective monitoring tools and practices can render them ineffective. Proper monitoring involves continuously analyzing log data in real time, setting up alerts for suspicious activities, and having mechanisms in place to respond promptly to potential security threats. The combination of insufficient logging and monitoring can make it challenging to detect and respond to security incidents, such as data breaches, unauthorized access, or malicious activities, which could have serious consequences for an organization's security and reputation. To address this issue, organizations should implement robust logging practices, real-time monitoring solutions, and effective incident response procedures to enhance their cybersecurity posture. SSRF. Server-side request forgery. SSRF is a security vulnerability that allows attackers to make requests from a server to internal resources, bypassing firewalls and security controls. Let's dive deeper into how SSRF works. There are two main types of SSRF: blind SSRF and classic SSRF. They are basically the same, The only difference is that in blind SSRF, the attacker does not get feedback from the server via an HTTP response or error message. Preventing SSRF is essential to protect your application and infrastructure. Here are some practical measures to prevent SSRF attacks. Whitelisting. Define a strict whitelist of allowed URLs or IP addresses that the server can access. Input validation. Carefully validate user-provided URLs to ensure they can't be manipulated for malicious purposes. Firewall rules. Set up firewall rules and network configurations to limit outgoing requests. Remediation. If you suspect SSRF in your application or infrastructure, here's how to remediate it. Patch vulnerabilities. Identify and fix the SSRF vulnerabilities in your code or configurations. Monitor traffic. Implement monitoring to detect SSRF attacks in real time and respond promptly.